Hello, and welcome to Inventors Helping Inventors. I'm your host, Alan Beckley, inventor of the Wonder Wallet. If you're an inventor searching for proven ways to make money with your invention, if you dream to see your product selling in stores everywhere, you've come to the right place. There's no better place to get help than from experts, inventors who've already achieved success. Every week, I interview successful inventors, asking them the questions you want to know. Tune in to learn from the experts so you can get your invention out of the tank and into the bank.
I was actually working for some years in automotive, and my automotive career was a lot too much documentation and not enough getting things actually done. So I started looking around, and it turned out that at least at the time, the whole regulatory structure of automotive and medical was very similar, and so it was easy for a medical company to hire me.
If you've listened to this podcast for a while, you've heard me talking about the Inventors Bootcamp, right? Over the last 3 years, hundreds of inventors have joined us in the Inventors Bootcamp, and we have lots of exciting success stories from our students. But guess what? The bootcamp is not for everyone. If you like to tinker with invention ideas occasionally on weekends, hoping that someday someone will buy your idea, the Inventors Bootcamp is not for you. If you think it's your job to just come up with ideas and someone else can take care of the rest, prototypes, packaging, and contacting companies, the Inventors Bootcamp is not for you. But if inventing really matters to you, if you know deep in your heart that you've got an invention ripe for success, if you're willing to learn and do whatever it takes to be successful, I'm here to help you, and the Inventors Bootcamp is your ticket, your next logical step forward. So, what is it? When is it? And how do you sign up? The Inventors Bootcamp is 5 days of live interactive Zoom meetings. Monday, April 7th through Friday, April 11th. For 1 hour each night. Teaches you precisely how to create a clear, concise marketing message, which is exactly what companies want to hear. When you join us, you'll meet other inventors, plus you get a licensing masterclass, and lots more. The next Inventors Bootcamp starts very soon. Monday, April 7th. Enrollment is open now. Just go to www.alanbeckley.com/bootcamp. Many podcast listeners, just like you, have joined the Inventors Bootcamp. Here are just a few of our success stories. Duncan Ashworth has 2 companies interested in licensing his COVID-killing floor sanitizing invention. Daryl Carter secured a business partner and licensing arrangement. His asthma relief product was set to debut last fall. And Julietta Hughes tested her portrait artist invention. Now she's got a clear strategy for reaching out to companies to license it. Ready to add your success story to our list? The bootcamp is your ticket. Register now at www.alanbeckley.com/bootcamp to save your seat in the April bootcamp. Welcome to episode number 497. Today I interview Rick Stockton. Rick Stockton's dad was a scientist who did a lot of R&D work. During his youth, the family frequently moved all over the eastern part of the U.S. Rick graduated as a mechanical engineer from Texas A&amp University during a time when the oil industry in Texas had contracted, so finding a job was tough. This led him to get a factory-based engineering job. For 15 years, he worked to ensure that other people's designs worked as they expected. Later, he transitioned into working for a medical company, helping to design medical devices. He really enjoyed the medical design work a lot. For the last 25 years, he has helped inventors and companies with prototyping and design in J.R. Stockton Consulting, his own consulting firm. He has 29 years of 3D design experience, mostly in SolidWorks. He particularly enjoys working with inventors to help bring their ideas to life through design and prototyping work. He and his wife have 3 children. They are enjoying life living in the San Antonio area. You'll want to listen to this entire interview where Rick shares why he thinks that softer skills are particularly important to ensuring a product design will work as planned. For example, the inventor must consider what the user's experience will be for customers of his or her product. Also, how inventors often design products for injection molding without thinking to factor in slight angles to keep the product from being stuck in the mold. And finally, why inventors must discuss with designers the ultimate end goal, where they may overspend getting a factory-ready product when they simply need a workable product to show and tell for licensing. Now, let's get right to our interview with Rick Stockton. Rick Stockton, it's a pleasure to have you on the podcast with us today.
Alan, it's good to be here.
Rick, I'd like to kick off by asking, could you share a bit of your background with our listeners? Like, where did you grow up and go to school? And what did you do before you began helping inventors with engineering and prototyping services? Could you share some of that with our listeners?
I grew up all over the eastern half, extending to Texas and going as far east as Massachusetts and New Jersey. My father was a scientist and a head of R&D, and we did change companies fairly often, 5, 6, 7 years. I grew up, went to regular high school, was pretty much of a C student until I got to 10th grade. We lived on a little island, and it was very boring, and there was nothing to do but study. And then I became an honor student.
That's an interesting story. In other words, to go from a C student to an honor student, and maybe the primary, if we want to say, mitigating factor is being isolated on an island where you can focus on studying. Was that an accurate portrayal of it?
There wasn't much else to do except to go to St. Francis Gym and walk the beach.
One last question, and then we'll move on. But which island was this?
Oh, this was Long Beach Island. At the time, it would be 100,000 people in the summer and 10,000 people in the winter.
Interesting story. Rick, on your website, you have an extensive medical device portfolio where you've applied your design expertise for clients. Can you share briefly with our listeners what attracted you towards that product segment?
It was almost a random thing. I'm glad I ended up there, but I was actually working for some years in automotive, and my automotive career was a lot too much documentation and not enough getting things actually done. So I started looking around, and it turned out that, at least at the time, the whole regulatory structure of automotive and medical was very similar. And so it was easy for a medical company to hire me. And that's when I started getting to do all the 3D things. And that was back in 97. So that worked out fairly well. And I liked it. And it requires a lot of precision, intelligence. You have to deal with a lot of regulatory stuff, a lot of headaches. It's not for everybody.
That makes sense. And what I'd like to take out of that to highlight for our listeners, you did, what they famously call a pivot from one industry to another, but you recognized that both of these industries had similar characteristics as regards to using your skill set. So transferring from the one to the other is something that would work out pretty well, because this is something people struggle with. As they say, yeah, it's time for me to make a change. Like when I left Boeing and then moved into telecom, that wasn't necessarily the easiest transition. I like that story that you looked at that and saw that it's something you could do.
It wasn't really so much that I had a grand design on all this. I graduated from Texas A&amp during a real problem in the oil field. And so the industry everywhere around me was glutted with engineers. I felt fortunate to find anything. And I always wanted to design, but this was manufacturing and process engineering. I've got a little animated cartoon on my site which tells the story, but basically I felt like I was marooned in manufacturing engineering, making other people's designs work on the manufacturing floor and troubleshooting for them. And then I found out that 15 years was one of the best little preparations you could have for actually doing design work, which I've been doing for the last, 27 years.
I like your maybe unintended pun in the sense that I too am an Aggie, go Aggies. And you
Yeah.
said marooned in the land of maroon and white. So there you go.
I never felt marooned there. I was working my way through school. I was busy trying to keep my head above water the whole time. And I changed it. Talking about changing professions, I changed majors twice. And when I finally ended up in engineering, I started with my C's started turning to A's with an occasional B. And I turned a grade point average that was literally in the dirt on the verge of failing out in all the way up to a 3.0. And anyone who's had to do any averaging, you know how hard that is.
That is hard. Also, you shared with me that you assist inventors and companies with a variety of other product design needs outside the medical segment. But I want to kind of shift gears a little bit and talk about something as you and I have chatted, and I know this to be true for you. You're passionate about helping to guide inventors to have a positive outcome in working with designers, whether that's with you or someone else. What are some of your best practices you advise them to use? Is there a sort of template, if you will, you give them what to bring, how best to outline their needs when working with a prototyper or an engineer? Could you share that with us?
Every inventor that I've talked to is excited about their invention, but the specifications needed and whatever prototype or handmade prototype they have and whatever sketches they have, they can get pretty much mixed up so that at the end of the conversation, there's some question about some of the soft things, some of the soft characteristics of it, like what is the user going to feel like using this device? What are they going to feel like after they've used the device? What is going to be their mental impression? What's going to be their physical experience, their hands-on? And things like that actually help me to make a lot of little decisions and be able to get back to them with proposals that they're more likely to enjoy.
You made a great point that I would really like to highlight for our listeners. And this is one that I feel very passionate about. And sometimes people hear me say it so much, they go, oh, there it is again. It's what I call the user experience. And that is inventors, as you just described, are very excited about their product. They think it's the greatest thing in the world. And maybe it is, but it's so focused on their product, their little baby, so to speak, that they don't think, okay, if this were in a store, or okay, when somebody buys and uses this, is it going to be easy for them to use? They understand how it works and how they can apply it. And if it looks like maybe it wouldn't be, maybe we need to make some design changes. I think all too often, and you just hit on it, that a mistake inventors make is they're so focused on their product that they don't think of the end user experience and making sure that's going to be a good one. Would you agree with that?
That can happen. And anytime you get an idea, it's pretty easy to get some ultra fine target focus, some tunnel vision just on one thing. And if you've got somebody that you're talking to who's just waiting for you to tell them what to do, if you've got a designer like, that's fine. But if you've got somebody who's willing to take a little extra time and discuss it with you and hear what you've got to say and ask you some questions, that's probably going to serve you a little bit better. I heard you talk before about qualifying a designer, qualifying an invention. And sometimes the innocent questions like, wouldn't you rather make that out of a polymer instead of a really heavy stainless steel, can really give you something to think about. In the end, I'll design whatever they want, but at the same time, I'll always try to make sure they've got the best feedback I can give them on whether it's feasible or not.
Once again, you made a point I'd just like to highlight very quickly. When you're talking with inventors, something that can come up is you will recognize that, okay, this could be made out of steel. That's what the inventor's thinking of. But steel, if they ever try to take it to market, is going to be expensive, and it may put the price point of the product for a customer to buy really too high, whereas perhaps the same product made out of polymer would work equally well, perhaps even better, but also the cost would be considerably less, and now it could make it more of a competitive product.
Sometimes what the inventor wants is a really big deal. For instance, do they just need something that will be a conceptual demonstration? It doesn't have to be nice. It doesn't have to work very well even. It just has to work a few times, and it will get them to that next place. It will get them through an open house or an investors meeting. Sometimes they need a prototype which actually will function exactly like the real thing. It may be a little bit of an ugly duckling, but it will do the job. And sometimes they would like something that is, we may use prototype methods to make it. We may machine it all on machine centers, but they want something that they could just turn that right over and say, hey, this thing, the way we designed this, you can injection mold it. You can make it out of sheet metal. You can do all of these things and send this thing off for quotes. So I try and make sure that I know just what the inventor is looking for, what their real goal is for their next step.
Well, and that's a great point. It's actually a perfect segue to my next question. And that is, you mentioned to me that you work to ensure that a completed prototype or design that you do for them can always be manufacturable. Can you give us an example for our listeners of what happens when a finished prototype is indeed functional, but it's not manufacturable? In other words, they could not take that product to a manufacturer in that form and have a bunch of them made. Can you describe a little bit about that, and what impact does that have on the inventor if they get a prototype that's functional in some sense, but could not be taken to a manufacturer? Could you share that thought with us?
Yeah, without giving away any of their secrets. I got a call from a friend of mine who is in regulatory, and all he is very important advisor, which helps you make sure you got all your I's dotted, T's crossed, and documents written to get through the FDA. And so an MD up there had developed a brace for a patient's arm. And it had a lot of important things, which I also don't want to talk about because I don't know how released this device is at this point. But it involved a series of less than a dozen interlocking plastic parts. The problem was that their injection molder gave them a no quote. They said, we will not quote on this part. And so they were really stumped. They were trying to figure out, we're stuck. We can't go any further. So I got called in. I looked at it, and after about 45 minutes, I was pretty sure we could fix this thing. And what it turns out to be is when you're going to injection mold something, you have to put certain angles on it. So whatever parts you're making will, when the molding is done, drop right out of the mold so it can go on a conveyor belt and go to the next place it has to go. All of the sides on this part were perfectly straight up and down, meaning almost by definition, it was going to get stuck in the mold. It would never come out. You'd have to pry it out with a pry bar. So the person who'd been doing the design was new at it, and they hadn't understood all the things that you have to do. They had sent it off to a prototyper and got back something really, really nice, quick prototype, and we're now stuck. I may want to actually describe this over again because that sort of went around in circles. The short version of it is that this client had a wonderful prototype that worked really well, but on half of the surfaces, it needed just a few degrees of angle so that it would work in the injection molded process. You couldn't possibly, they had made one out of additive manufacturing, great, like SLA, but you couldn't possibly make it in an injection molding machine. We went through that, modified everything, and there were parts within parts, a little like a Russian egg doll. And so we had to do a lot of little modification, but in the end, everything worked perfectly, and they were able to get right back on their road. So manufacturability can stop you dead, or it can make it really expensive to make, or it can make it possible to make, but you get a lot of flaws. And manufacturability can make it hard to make a device that is really high performing. So making sure this is covered is a big part. And if they want this thing to be able to be sent out for quotes, it's got to be ready.
You made several great points there I'd like to hit on in a way that I've never heard from anybody say it before. It's a little bit like, I think Stephen Covey said, start with the end goal in mind. And this is this sort of thought process. But as the engineer in me is listening to this and you're talking about injection molding, what I'm picturing is if somebody injection molds, let's say, a perfect cube, orthogonal, to use a fancy word, 90-degree angles and all the rest. Well, functionally, that's great, but it's going to be hard to get that out of the mold because it doesn't have any kind of spare tolerances space, where if instead of being the perfect cube, as you described, it's got a slight angle, so it's technically a rhomboid, where it slides out of that mold very easily, but the function works just as well, even though there's a slight angle there.
That's right. If your thing is not manufacturable, you're going to suffer in all areas and maybe be completely stopped. If it is manufacturable, that's going to give you a lot of flexibility. You're going to be able to run it under a lot of different conditions. You're going to be able to run it at higher speeds, so it's going to cost less money to make. And with things like injection molding, you'll have less operator intervention required to pull these things out when they finally do get stuck. And again, that's going to reduce your costs.
Another quick thought that just hit me as you were describing that is people forget to put tolerances in their design sometimes. They design something perfect on paper, but then when they put it together, it doesn't work if it needs to rotate in some fashion. I think of the example would be like a door hinge. If you made a door hinge without 1/8 of an inch or 1/16 of an inch of gap or space or whatever, it'd be a great hinge, but it would never open because there'd be no tolerances in there.
It would be squeaky at best. And you can find that in so many things. If you've got a rod that extends, you pull it and it extends, and there's a smaller piece inside that and a smaller piece inside that. Everybody's first idea is just have some slightly smaller rods. No problem. That'll make it work great. Except it won't, because in real life, some of these parts will warp a little, some will have tolerances, some will have manufacturing tolerances, and different materials will expand and contract at different speeds, depending on their wall thickness and the materials that they're made of. So you can run into all that kind of stuff. What is the answer? Sometimes the answer is just designing things a little differently. From the outside, it still looks the same. From the inside, instead of having all of those cylindrical surfaces dragging against each other, maybe what you've got is, on the little inner cylinder, it's got a bunch of spirally ribs, which keep everything aligned, but keep your surface area down to almost zero, so the thing will slide right out and do what it's supposed to do. That's just one example, and I'm sorry if I've lost anybody in that description because we don't have a picture to show you or anything. But knowing how things work can make a gigantic difference in how things are designed. You may not see it from the outside of the device. It may look exactly the same, but the difference is it'll work, and it'll work well, and it'll be as inexpensive as it can be, and it'll be easy to manufacture. So you'll be able to send it out to 5 different places and have them all competing for your business of making that part.
I'd like to transition just a bit and ask you, what would you say is the biggest challenge that you face in working with inventors? Do you ever find that the inventors come to you before they're really prepared and ready to work with a designer? And if so, what advice do you typically give them? Could you share that with our listeners?
You asked before why somebody would want to have a prototype that really wasn't ready to manufacture. And there's a great reason for that. Very often, it's much cheaper to create a prototype that is not ready to manufacture or that would not hold up in the actual environment in which it has to function, but which can be demonstrated to work perfectly well on a showroom floor or during a demonstration or in front of an audience. And the reason you make those is because sometimes you have to get some investor money before you're really ready to come up with something that's very realistic and has all the complexities and all of the options that you want it to have. And to get people to believe in that, you have to have something that's simple to demonstrate, a conceptual 3D illustration of something that you can just activate, move, or do whatever it's going to do. Now, those things can be way less money to cost. In fact, I had somebody come to me, and that's really all they needed. And I said, you don't need an expert CAD designer to design this for you. You can get somebody who's in college, who's taking their first or second course in SolidWorks, and they can design this for you, and they will do a good job, and they will charge you much less per hour than I do. My fees are somewhere between your plumber and your lawyer per hour if we do it that way. And that same kind of cost goes into larger cost estimates and things like this. But you can save yourself a ton of money if all you need is something that you can make work in front of an audience to demonstrate that you've got a great idea. So you asked why you wouldn't want everything ready for manufacture, and that is because it's expensive. It could cost you thousands of dollars to do that, whereas you might be able to get somebody for a few $100s just to crank something out really quick that still gets you enough so an investor is going to hand you $10,000 and say, here's your first tranche of money to develop your concept.
Made several great points, and we also ended up playing a little bit of the devil's advocate, because earlier we're saying, hey, it's important to make a prototype that's ultimately manufacturable, with a caveat that if that's their goal. In other words, I really want this to be manufacturable because that's going to be the next step for me. But now in this question, you said in so many words, what if their real goal, initial goal, is really to get something low cost to manufacture that's a show and tell item that is never really intended to go directly to be making thousands or tens of thousands of them yet, but it's the next phase, the next step, and they're trying not to spend too much money to get something that they can demonstrate, but knowing that to get to the next level might require spending a lot more money. Did I get that right?
You not only got that, but when you're providing a service to somebody, and that's what I do. For instance, I've helped some of my clients actually develop patents, and my names are on them, but because I'm working for them as a service, I don't make money off those patents, and I don't own that IP. When we're all done, they still own everything. The cool thing is that if you've got somebody who's doing a good job for you, they don't have a formula or a standard thing they want all of their customers to do. They're trying to work with you to figure out what you need and make sure that you get there. Nothing grossly more and certainly nothing less. And if you've got somebody and they're helping you do that, you've found a good helper.
And a point that I wanted to take out of that for you, because it's an issue that inventors run into a lot, and that is when they're working with somebody who's a designer or prototyper, they don't think about approaching them and making sure that in their contract with them, it stipulates that, hey, I, the inventor, own the IP. You're never going to have any financial interest in the finished product. I'm going to pay you for your skill sets to produce what I need, but that's where you fit in. And I think that's something important to do. And I think it's really laudable that you take the approach of purposely designing your contract and working with inventors so that what you own is helping them create a great design. You don't own any of the IP or any of the product in the end.
Sometimes part of doing what I do is helping the inventors learn what they need to do to protect their IP. I talked to a man just within the last 2 weeks, and I don't even know if he would have made me sign something before he showed me something. But I said, you not only need to get me to sign that, but everybody you show it to, you need to get them to sign something, you basically an NDA, a non-disclosure agreement. You need to get them to sign that just so that you can say when you finally want to sell this idea to somebody for licensing or something like that, you want to be able to say that everyone who saw this signed an agreement, which of course I have on file. They want to know that you're working as hard as they're going to work to protect that intellectual property, that IP.
That's such a great point, and it's something inventors really need to be attentive to. As we roll towards a close, I'd like to ask you, are there any parting words you'd like to leave us with?
Sometimes inventors can be a very solitary lot, and it's part of an amazing personality. They're inventors, people who are developing products, people who are coming up with the new ideas. In a sense, they are my heroes. They're also my employers. And But sometimes the sole inventor can find that they've isolated themselves. Everything is a secret, including their identity. You don't want to share the secrets of the things that you're inventing just to everybody, but you do want to know a lot of people who know a lot of different things. You do want to be at least a little bit of a social creature. You want to, in short, network. LinkedIn is a great place to start networking. People that you know locally, people who do machine work, maybe people who do the kinds of manufacturing that might be interesting to you for making your prototype. Who knows where it will be manufactured in the end, but you're going to want somebody who can machine this thing. One of the things that I've done is I've got a huge network of people who have expertise in everything from materials, metal, plastic, machining methods. I've got people right here in San Antonio who can do unbelievable things and at a reasonable price and a good turnaround rate. And the more people that you get to know, the more easy it will be to discern if you're dealing with the right kind of people. The only other thing that I would say is that there are no shortcuts to telling the truth. There's no shortcuts to being a good person. There's no shortcuts to being someone that someone can count on. And there's no shortcuts to genuine constructive reciprocity, giving and taking. Even with all of our computer technology and even with everything that we've developed and all of the stuff, when I started my first drafting class 49 years ago, we were doing everything with pencil. I've seen a lot of things change. But one thing that has not changed is that you want to make sure that you're dealing with good people. If you're not, no technology can save you. Nothing can save you. If you're dealing with people who are willing to cut corners that should not be cut or say things that are not true, it's going to be rough. And I've had people who wanted to do that, and I tell them, don't take those shortcuts. Wait it out, find good folks, and network. Especially if you're a bit of a loner, join some group like Alamo Inventors here in San Antonio, or find some group of people who are innovating and hang out with those people a little bit. True, you've got a life, but inventing, I think, is part of your life, and knowing other people is also a big part. So that was a big last word, but it's just one big ball of yarn, which is really full of color.
You made two key points that I really want to highlight real quickly here. And one of them is you said, deal with good people. Do your due diligence to make sure you're dealing with good people to have good end results. And you said this magic word that a lot of inventors sometimes cringe from, and that is you need to network. And the more you build a network, don't just be the complete lone wolf. And, you spoke about being part of groups such as Alamo Inventors, which is a fantastic inventors group. And that's what I've been doing, a little commercial here, for the last 6 years. We do our monthly boot camp for inventors, and I've had some people attend 20 boot camps. Why? Because it brings a group together on a regular basis, and they're able to do that kind of valuable networking and exchange ideas. I do that also with a monthly membership group, et cetera. So that's part of my mission, if you will, is to help inventors to see these things more broadly and not to be just the lone wolf, but to reach out, join with others, work with others that can help them be really more successful and efficient with what they're doing.
I couldn't recommend it more highly. I will have Texas A&M undergrads calling me, and they're juniors and they're getting ready to graduate. And I'll say, how well networked are you? And they'll go, what? And I'll say, everybody you know in your classes who is smart, who has a good attitude, who is honest. Connect with them on an environment like LinkedIn. That's where most of the professional people end up sooner or later, along with some other pretty interesting forums. But also connect with your professors, connect with anybody that you work for, connect with anybody that might have constructive things to say about you. I really wasn't very connected until about 16 years ago when I started my consultancy, and it really showed. It took a while to get caught up, but boy, was it worth it.
My final question for you, Rick, is how can our listeners reach you if they have other questions or if they would like to learn more about how you could help them?
The easiest way to reach me is on my site or just email me. And I'll spell those things out as slowly as I can. My site is JR and then my last name, Stockton. It's like Fort Stockton, Texas. It's the same spelling as Stockton, California. And when people look at my site name, oh, it's Junior Stockton. That's fine. JuniorStockton.com. And my email is really similar. It's my first name, Rick, at JuniorStockton.com. And those are really good ways to reach me. And if you've got a question and there's just something that you're just kind of any idea on how to do this or this, I've always got a few minutes. Just be sure you name drop Alan so I know where you're coming from.
That's fantastic, Rick. And just to highlight, you did a really good job of spelling it out, et cetera, which a lot of times people don't do. But essentially, your site is JRSTOCKTON, JRStockton.com, or as you said, JuniorStockton.com. They can find you very easily there, as well as your email is rick@JRStockton.com.
That's it.
So, Rick, I'd like to thank you so much for being on the podcast with us today and sharing your journey, your adventure, and the things that you've done and continue to do to help inventors. And I'd like to reserve the opportunity to maybe get with you in another 6 months or a year to see what you've got going on at that time. So, once again, thank you so much for being on the podcast with us today.
Glad to be here. Thank you for the opportunity.
You bet. So, you're done searching for your product, and it's not out there. Yay! Maybe you filed for a provisional patent and done some marketing research or surveys. Heck, maybe you've even created a rough prototype, then found that, although it kind of works, it looks like something from the Stone Age. You'd be embarrassed to show it to your friends, much less to a manufacturer for a licensing pitch. What if I could put you in touch with a guy who offers free consultations, takes no money down, no money up front, and will give you a quote on your project before he starts? What if I told you that this same guy can help you design your product and make you a virtual prototype before you ever put a penny into building a physical one? What if I told you he could make you patent drawings, CAD files for manufacturing, and even make marketing videos and build you a website? If this sounds like someone you want to talk to, let me introduce you to my first podcast sponsor, Brian Keast at I Draw Dreams for Inventors. With 3.5 years of trade school and 15 years of mechanical experience working as a mechanic for General Motors, you have someone that's seen design failures and how they were fixed. Also, he had a 25-year career as a general contractor who designed his own houses and remodels on computer-aided design. In getting plans through countless building departments, he gained a tremendous amount of experience by working directly with structural engineers. The many years of combined experience in these two careers gave him a unique look into stresses and failures in design. He brings this wealth of knowledge and experience to his company, I Draw Dreams, as the CAD guy who will design a product for you that will work. Every inventor I've referred to Brian has come away delighted with the work he has done for them, and I think you will too. Just make sure to tell them that Alan sent you. Thanks so much for tuning in to Inventors Helping Inventors. If you like the show, please tell your friends about it. Make sure to subscribe in iTunes or wherever you get your podcasts so you won't miss a single episode. Talk to you soon.